In this video, we will see how to generate a matrix and perform some basic operations on matrices. Okay, so we will define a matrix A equal to, in this square brackets, say 2, 3, minus 4. This will be the first row, and to go to the next row we will have to use this semicolon. Okay, so the elements of the next row will be, say, 5, 4, 9. Then third row will be defined as 1, minus 3, 7. Okay, so this is the matrix which we have just defined. Okay, now we can access any element of this matrix by specifying its index. Now we have to define the row number as well as the column number. Suppose I want to access this number 9. What I need to specify is row number, which is 2, and its column number, which is 3. So I have to write here 2, 3. So in this way we can access this entry. Now we can correct any entry in this matrix A. Suppose here in place of 3 I want to change it to, say, 8. Then what I will require to do is A, this is in first row and second column, so I will need to do 1, 2 equal to 8. Okay, so now you can see this entry has been updated to 8. Now I can define any submatrix from this matrix A. Say B equal to, I want a submatrix which contains only the second and third row. Okay, so I have to specify A. I have to specify this both row, that is 2 and 3. So I have to write 2 column 3 means row number 2 and 3, and then columns 1 to 3. Okay, so you can see that the matrix submatrix B has this row and this row. Okay, now suppose I want to delete any row or column or an entry here. What I need to do, I have to equate it to the null matrix. Say I want to delete this column, so what I would do, sorry, so what I had done, I equated this second column equal to null matrix, then on this particular column will be deleted. So here's the new updated matrix B. Now I can perform some operations on this matrix B. Suppose I want its transpose, so let me define C equal to B. Using this right quote mark I can find its transpose. Okay, now suppose a matrix which has its entries as complex number, say 2 and 3 plus 4i, then 3 and 2i. Now if I perform its transpose, then what I will get its conjugate transpose, say D prime. So this will give me 2 plus 3, 2 plus I, then this 3 minus 4i. Okay, so you can see that this is conjugate transpose. Okay, now uh, we can append a row or column in the original matrix. Say this is our matrix A and I want to append a row or a column in this matrix. Say let me define u equal to say 1 1 and 1 and some v equal to 2 2 and 2 column vector. Now I can append this row and column in this original matrix A using the following. So this will append the row u vector uh, below as a fourth column here, fourth row here. Okay, so similarly I can do this, which will append the fourth column. This entries vector v as a fourth column in the matrix A. Now we can find some parameters of the, or we can perform some calculations on this matrix A. Say suppose I want to find the determinant of this matrix, then I can use the command det and A, so I will get its determinant. And suppose I want its eigenvalues and eigenvectors, so I can define, I will use the command eig, say eigenvectors, eigenvalues, these are variables, and using this command eig I will get the its eigenvectors and eigenvalues. So this is eigenvalue and corresponding eigenvectors are given here. So for this eigenvalue, this is the corresponding eigenvector and so on. Now we can use some commands to define matrix. Say I want to generate a matrix of all zeros, so what I can use zeros command and say a matrix of 4 cross 4, so this will be all zero entries. Similarly I can use this command once, which will generate a matrix 4 cross 4 matrix having all entries as 1. And suppose I want to generate a diagonal matrix having the diagonal D as say 2 4 5, then what I need to do, I have to use the command dig and D. So this will generate a square matrix with this diagonal D. Now the same command can be used to extract the diagonal of any matrix. Say this is matrix A and if I use this command, then this will give me this diagonal as a column vector. Okay.